Hey everybody, this is Jeff here. This is our Module 2 material that I want to present here. As we get into this week, we're going to learn about variables and how to assign them and how to operate on them. So from your home page, excuse me, you can click on Content, and you probably know how to do this by now, but to be clear, the module that'll come up by default is usually based on your like where we are in the calendar. I happen to have module 2 up, but if it doesn't show up, you should get it from the table of contents here. And if you click on it there, it'll show up here. Let's walk through what the module has real quickly here. We got a persona that we talk about, and you can read what she says here. Um, and there's an overview page, the discussion for this week, the assignment, and a summary page. Let's take a look at the overview real quick. So we're going to talk about variables, which is really the kind of think of it as the parent word for how we store data and how we access it and how we enter it. One of the key fundamentals of writing a program is to be able to get information from the user and do something on it and then get the information out to the user, right? And so variables are locations in memory that you will use to execute the objectives of your program here. Okay, we're gonna cover a good amount of this in this video here, um, and I'll walk through the intention for the discussion project and the assignment, of course. Um, but I think where I'm going to start here is I have some PowerPoint slides that I will post here with this video. And we'll do some interactive stuff in Replit to kind of demonstrate some of these different things here. Okay, so let's start with, not with the recap. Let's start with one of the most common mistakes that I see more often in 160 than 161. But some of you have probably already made this mistake already. And it's really just treating assignment statements like algebra, right? And if we look at these three statements here, these are all examples of statements that you might write on a whiteboard or on a piece of paper if you're doing some algebra work, right? Where you have numbered values and a single equal sign and some you know single character names that represent unknowns, basically. Usually the letters are in algebra are considered unknowns, right? Really no difference as variables in our context here. These are all, I think, these are all legit algebraic statements, but none of these work inside almost any programming language here. So assignment statements is what we're talking about here. An assignment statement in C++ and most programming languages, not all, follow really two rules here. You have a single variable on the left side of the equal sign. So we're doing one assignment at a time, and that assignment is to the variable on the left side of the equal sign. Okay, so if we pop back up to the previous slide, that's why this is illegal here. That's why all three are illegal, actually. Okay? And so these are assignment statements. Actually, they're not quite. Let's fix that. In C++, an assignment statement will have a semicolon as the delimiter between two assignment statements. Okay? So now let's talk about what makes up an assignment statement. Okay? And so there's a bunch of C++ terms here, programming language terms here. You will mix these up, right? I see these get mixed up all the time. That's okay. But I want to do a deep dive on this and talk about what each one is. Okay, so we have a single statement here: x is equal to y plus 2. This is the statement is this whole thing. Okay, this number 2 right here is called a literal. A literal is a value used in a line of code that cannot be modified. That could be a constant. that you may have declared and created earlier in the code, or it just may be, you know, a string or a number in a line of code like this. This too cannot be modified to something else. And that's called a literal. This thing on the right side of the equal sign is the operation. Okay, so the operation is an addition of a variable, the contents of the variable y to the literal 2. And that's what we're going to do as the operation. Okay, I'm going to add something here. Operator, in this case, is an addition operator. The operator is the actual technical calculation or manipulation we're going to do. In this case, it's a plus sign, and it's doing the addition operation. If we change that to a minus sign, it would be subtraction, right? Okay. These two items are operands. So any individual piece of data that's used in an operation is called an operand. So we have y as an operand, and 2 is an operand, and a literal. Okay. The equal sign is the assignment operator. And so we're going to do the operation on the right side of the equal sign. It's going to result in a value. And we're going to put that value into the variable named x on the left-hand side of the equal sign. And so we put all this together. These are all the different pieces. Actually, let's get this guy in there too. Let's see if we can make that fit. Kind of. We'll do that. Okay. So there's a little bit of a reference sheet there for you on the difference. A common thing I have from students, and they'll send me a line of code and they'll say, how come this expression's not working? Or you'll use the wrong terminology here. It's not a big deal. We're learning this syntax. The subtleties between calling something an operation and a statement is small, but you want to be aware of that, obviously. Okay. One more thing on variables, and then we'll jump into Replit here. In the book and all over the place, you will see the word variable and you'll see the word identifiers. They are two different things. A variable is a location in memory or a space in memory, and the identifier is the name of that variable. I will use these interchangeably almost all the time. I will talk about a variable called, ABC. I really should call that an identifier for a variable. And so don't worry about that. If you find yourself on the rabbit hole of Stack Overflow or something like that, you're going to hear talk about, well, the identifier could be used in this way because the structure may not be the same, and you might identify a function versus a location in memory, which is true, but it's outside the scope of this course. Okay, the book uses both, and so I wanted to call this out. All right, let's jump in to do some code here. So here's our very basic template of code. This is not going to do anything. There's nothing to do right here. Okay. So I'm going to walk through a few things here. I don't know what the code will end up like at the end, but I have all the different kind of steps that I'm going to demonstrate, already entered. So I can post that as well. It may not run because it has lots of different stuff, but you'll be able to reference it if you want. Okay, so we're going to say a variable must be declared. Okay, so let's see what happens here. Okay, I'm going to try to print out the value of the variable x. And I get an error here, use of undeclared identifier x. Okay, so again, using our terminology, x is the identifier for the space in memory, and it's saying, hey, you haven't declared that. Okay, so let's declare it. See what happens. I got another error. Now it says it's uninitialized when it's used here. Okay, so it's basically saying that it doesn't know what that value is. And so we have to, and initialized. So we can do this one of two ways. We can do it like that. Let's run that and make sure that works. Okay. Or we can do it like that. Both of those will work. Okay. Okay. You hear the typing and it's off screen. I'm just making a note here to make sure that the document I provide you at the end is updated. Okay, so now that we've declared and initialized our variable, we're able to use it here. Now, what if, so step one is declaring and step two is initializing. Step three Okay, so what about this case? I have a variable and I want to have the user enter that. Okay, let's see if this works, right? Because I'm asking the user for a value and I'm going to print out that value. Let's see if that works. So I enter a value. I'll enter negative 699. And it says, thank you for entering 699. So the answer is no. I don't have to initialize the variable if I know I'm not going to use it until I assign it later. This is essentially assigning it, right? However, it is a good practice to always initialize your variables because you might find that this line of code, line 13, and these lines of code are like hundreds of lines apart in your code. And it may not be obvious that that value has been used or not. So it's always good to assign to initial values. There's tricks here. Like you could assign to like known bad values. So if a known bad value shows up, you know there might be a problem here. And I'll show you an example of a bug in a little bit here. Okay, so now remember that assignment statements require to be okay, so we talked about this a little bit earlier, right? So here's an example of this. Let's see. Okay, I want to take the variable x and I want to add 1 to 99 to get a value of 100. Let's see if this works. So I get an error here. It says the expression is not assignable. Okay, this is your signal here that you're not following the rules here that I described earlier, right? So this is wrong. Instead, you want x is equal to y plus 1. And then we have x is equal to 100 now. Okay, so remember that assignment statements require the variable to be on the left side of the equal sign. Okay. This is a interesting distinction that occasionally somebody will get tripped up by. Okay, so if I create a variable and I create another variable and I say b is equal to a, what I've done is I've assigned the value that's inside a, or sorry, I've taken the value that's inside a and I've assigned it to the variable identified by b. Okay, so if I print this out, okay, we expect this to work. Yep. Okay, but note here that we did not actually move the value. We copied it. We didn't destroy, change, empty a by moving, by assigning, by doing this assignment. This is an important distinction here because in in legacy documentation and descriptions of programming languages, this is often called a move operation, even though it's actually not moving the data. It's copying the data. And I can see that sometimes students get tripped up by that because they assume that once they run this statement right here, that A is now empty or it's unassigned, right? Or uninitialized or something like that. And that's not true. The data will always stay behind. You'll just replicate the data. Okay, so this is an important point. Okay, we'll come back to that. Okay. Never is a strong statement to make. There's certainly programming languages and functions or whatever where you'll actually carry the data over and destroy what's behind. But generally speaking, when we talk about a move operation, we usually mean it as a copy. Okay, so next. So what if we have the same variable name on both sides of the equal sign? Q gets calculated to 99 times 2. 99 times 2 is 100 times 2 minus 2, which is 198, right? And so what this, again, if we go back to our diagram here, right, we're taking this operation and we're doing the calculation and then we're assigning the value to this. We've already used what was in there, right? So we're going to effectively overwrite that space in memory with the new result. Okay, you don't have to do it this way, right? You can do this. You can have, actually, you can do something like this, right? You can separate it if you want. I'm going to get the same result here, I think. But it is common practice to basically, it is common practice to do statements like this as you're compounding a variable over and over and over, right? As you're using it over and over. For example, you might have a counter and you're going to add 1 to it and add 1 to it and add 1 to it and add 1 to it. A clock would be another example. You're continuing to modify that value of that clock over and over. You don't need extra variables to do that. Let's talk about name convention now, because I've been using A, B, and I, and Q, and Z, and things like that. But when we write our programs, we're going to want descriptive names. And the good thing about the book, and let's take a look at the book here. I've gone through some of the information in the book so far, and let's catch us up to where we're at. As you go down here, I really strongly encourage you to do every single one of these. What I find here is that students will jump ahead and they'll miss some subtle thing that'll just trip you up. It's some silly thing, and it's really best to just go through these little by little. We've talked about assignments here. There's some ways for you to check against here, right? Like for example, this guy right here would not be valid because I have more than I don't have a single variable on the left side of the equal sign, right? So that would be invalid, right? Okay. Here's the example of using the same on both sides. Here's some examples of initialization. And here's where we're starting to use variable names that are like descriptive, right? Num houses is equal to 99. Okay, so let's talk about that for a little bit here. You want to make your variable names descriptive. You know, total before tax, initial temperature, final temperature. Sometimes I'll get students that'll use single letter variables for every variable in their code. That's generally not good. Occasionally I'll get students that will use arbitrary variable names. Like they'll call a variable flower and another one, you know, the name of a band, and they'll, you know, their pets' names and things like that. And that there may be an association for you as a developer, but for other people who are looking at the code, there certainly isn't. And that just can create confusion. Okay. One thing that I want to highlight here is if you look at, for example, this initial temp right here, you notice that the T is capitalized, but the I is not. Okay. This naming convention, and here's another example where the first word is not capitalized, but every subsequent word is capitalized, is a very common convention called camel case. And the word, you know, the term camel case comes is because you think of the capital letters as humps, right? So your camel's got the hump in the middle, right? That's where that comes from. This is one of two very, very, very standard naming conventions that exist out for most programming languages. You can also use underscores. Let me ignore that so you can see. There we go. These are underscores here. This horizontal line that's at the bottom is called an underscore. On most keyboards, that's the shifted version of the dash, right? So like, for example, over here, there's my dash and there's my underscore. You can see they're different, right? On my keyboard, I think that's on most keyboards here. There's a set, yeah. So your underscore is going to be your shifted dash. The underscore is not a numeric thing, right? It's not a numeric operator like a dash can be. In most programming languages, you can use it as a way to create some spacing, which makes things more readable, right? So this is a preference thing, right? This is readable. This naming convention is readable to me. This naming convention here is also readable to me. I prefer this. I don't care which one you use, but don't mix them and mix and match. If you have code where you're using both of those, that I'll flag that. This key rule here is to be consistent. So you'll usually see that I'm consistent and I will use just camel case, for example. Also, names are case sensitive as well. And so hello there with a capital T here and a hello there with a lowercase t are two different variables. You want to avoid this at all cost here. So let me demonstrate what that might look like here. So if I run this with hello there, what is it? Unused variable. Okay, so this is worth pointing out actually. It's complaining to me that I'm not using this variable. It's telling me, hey, you have a variable and it's unused. This is actually a clue that there might be confusion there, right? And so let's change this to use both to get rid of that warning there. In most programming languages, that's actually a warning, not a, what did I do wrong here? Okay, there we go. Get rid of that result. Okay, so in this case, I took my 1 and I multiplied it by 100. I may have wanted this, right? The point here is it's super easy to get that mixed up, right? Super easy. You want to avoid this at all cost. There's other interesting things here. Ones and L's look very similar, right? Capital O's, which I can't find on my keyboard, and zeros, depending on your font, could look similar. L's and ones are really tricky depending on the fonts here. So you want to be really careful here. And using, this is not a password, right? This is not you're trying to make this thing, tricky or whatever. Just be very careful with your namings of your variables here. And you want to avoid at all costs the same variable name where just some letters are capitalized and some are not, because you'll run into these types of bugs. If we go back to the book here, let's see if we just keep going, kind of going back and forth here. Here's some examples of assignments that we've talked about. See, we're getting into some more complex stuff. That this is the type of stuff that I want everybody to be able to go through. And as you work through this, you're going to basically be able to validate the stuff that we've been talking about. Why is this an error, for example, right? This is an error because I have my literal on the left side of an equal sign. Remember that the variable I want to assign must be on the right side of the equal sign. Okay, let's keep going. All right, here in section 2.3, lower camel case is what we've talked about. I mostly see it just referred to as camel case, not lower camel case. That just means the first letter is not capitalized. That is a convention that is mostly used here. If you look at some of these variable names here, this guy is okay. Ending with an underscore is okay. This guy's not. You can't start with a number. Starting with an underscore, you can actually start with more than one underscore. There's actually, looks like there's 3 here, right? Not a really good convention. Okay, this guy is not okay. It's got an exclamation mark as part of the variable name. That's not allowed. This guy's got a space. That's also not allowed. Again, most programming languages follow the same conventions. There are some exceptions here. And so go through this stuff on your own and make sure you feel like you get good handle on this. And so here's some example of the camel case here. Yeah, this is like a trick question here. UCLA should be fully capitalized in all these examples. All right, so if I had written this, I would have had num students, UC and UCLA, all, but this is a good example. This is okay too. Again, but I would have the C and the L and the A all capitalized here. All right. Compound operators, I want to come back to that. Yeah, this is important, these reserved words. Let me show you an example of what that means. So I can't declare a variable named int. Let's see what happens when I try to do that. Yeah, I can't. It gives me some maybe confusing error message. These are a list of the C++ reserved keywords. Most of these you haven't seen yet. You'll see more of these throughout the class, like while and switch and throw and else and so on. So if I take else, for example, same type of error here, right? So you can't use a reserved word as a variable name. What you see here is that this is colored blue, and you can see the same here, your development environment. And as soon as I make this not a reserved word, it's back to a black number, which will work. Now I'll just get an error that I've created this variable and I'm not using it, which is okay. All right, so let's keep going. Okay, we talked about all this earlier on. So my slides don't fully follow the order of what we're doing here. One thing that I haven't done in my demo here is kind of a more complicated formula here. Okay, so maybe we can fiddle with that for a little bit here. All right. Okay, let's see what happens here when I run this. It should work. Okay, so I get the answer of 40 here. Let's see what happens here, right? It doesn't look right to me, does it, right? Oh, it does, sorry. So A times A is 10 times 10, which is 100. And B times C is 20 times -3, which is minus 60. So 100 plus minus 60 is equal to 40. Okay, the most programming languages will use an order of operations where, in this example, we are going to multiply. We'll do the multiplication first here, and the multiplication first here, and then do the addition. Right? I think many of you know this, I think, as PEMDAS, right? As the acronym for all the basically the operations and what order they come in, right? And so multiplication and division will happen before addition and subtraction. Now, can always add parentheses. Like if you look at some of my production code and I'm trying to do stuff like this, I would do it this way. You would see parentheses here, even though these parentheses don't change the behavior of this example. The parentheses are just helping. They're just showing more explicitly what I'm expecting the results to be. Now, if I want to actually modify the order of operations, I can do that as well. Okay, so in this case, I add A plus B together, which is 30. I multiply that by A, so that's 10 times 30, which is 300, times minus 3 is minus 900. Okay, so parentheses are your friend. There's no reason not to use them. And in fact, what you could do is you can do things like this. If you're having problems with your equation not getting you the values you want, you can create intermediate variables here, and you could print them out during your development. Okay, let's talk about compound operators next. I think I'm at step 8 or maybe 9 by now. Okay, so I run this. I'm going to get A is going to be 100 and B is going to still be 99 because I haven't done anything to it yet. This we already know. Now I can, instead of saying B is equal to B plus 1, I can do this. This is a shortcut here. All right, this is called a compound operator. And whenever you see a compound operator, it is basically saying that I'm going to take the variable that I'm using on the left and I'm going to use it in the I'm going to use it in this operation to add to this. I learned compound operators, boy, I want to say forever ago, 30 plus years ago, and I hate them. I don't use them. They're not intuitive to me. I don't, to me, it's like, just write this, right? Just write what you want to do. But you will see a lot of use for compound operators. In C and C++ especially, there's a notion to make your code small and to be tricky and show that you can use these clever ways to have less characters in your program. And I'm a fan of readability. You can use compound operators. Don't get me wrong. You can use them. We show, here's 4 of them right here. Sorry, yeah, 4 of them right here. 5 if you include the plus that you'll see here. Where are we? And we're in section 2.5 on the book. Okay. All right. Last semester in my CS 160 class, I had a student who was running into trouble because they were doing something like this. Error. Got an error there, right? This is super readable, right? This is a super readable version of 1 million, but most programming languages don't allow it. And so you have to do this without the commas, which means you do lose some readability. By the end of this class, you'll be able to write a program to take an integer and print it out with commas. You'll know how to do that. And you could probably write a program to take in the input where somebody could type with the commas and convert that into the valid amount here. But for now, you have to basically accept that you're going to run these things without commas, which means if I ask you to enter a trillion, it's like, crap, is this right? It's like, there's our thousands, right? You kind of have to do that kind of stuff. But, just something you have to manage. All right, let's keep going here. We have some examples here as we work down the book here. like here's a good example of a fairly simple piece of code here, and some questions that it'll ask you about that. Which variable is used for the user's age in years? If you look here, I have a prompt where I'm going to enter my age. So whatever I type in is going to get into this variable. So this is a good candidate. So you can do that and you get the correct answer. Go through each of these guys. And if there's stuff that's confusing, we can have a follow-up session and we can walk through some of the examples. These are great simple examples. All right, now let's talk about floating point. Okay. Just a reminder, and I can put this in the slides actually. Floating point is the programming vernacular to represent real numbers. Just like integer is the programming vernacular to represent whole numbers. Right? So the idea behind floating point is that we're going to use a data type or a structure in our software that lets me, examples of floating point, 2.22222, 0. Those are all examples of floating point. The number 2 is also an integer, right? There's other floating point representations of irrational numbers. Everybody's favorite number, pi, square root of 2, 10 over 3, like 1/3. These are irrational numbers. You got to represent them in some way. They'll have inaccuracy challenges, right? And when you're doing detailed mathematics and programming outside the scope of our course, some things that you have to be very careful about. Okay, so let's go through an example here. Okay, so when I run this guy, what is it doing? Finally. Okay, so notice that I just get, it just prints out 1, right? It doesn't print out 1.0. Okay, that's because the this console output is trying to be smart, right? And so what we have to do, if we want to specify the precision we want to print with, we have to use a structure called set precision. This is it's either in the discussion or the programming document, right, where you can get this. But what this is doing is it is going to set and automatically print my values to 2 decimal places. Okay, so you can see that it worked that time. In order to use set precision, you have to include this library, IOmanip, which stands for IO manipulation. So I added that here. Over time, your standard libraries and things that you're going to have up here, you're going to have 4 or 5 of these that you're going to use in every program, and that's okay, right? You can include IOmanip all the time, regardless of whether you use set precision or not, or anything else that's inside there. Okay, so I can change the set precision to 4 if I want. You can see it modifies the output properly here. There is some tricky problems with floating point. And because of the way that the numbers are stored and operated on inside the hardware and the operating system, they're prone to having interesting inaccuracies. Most of the time, you're not going to have this problem. But let me show you. And I'm going to describe the difference between float and double here in a moment. So bear with me. I'm maybe doing that out of order here. Okay, so I'm taking two relatively innocuous values, right? These are just, I mean, real values, right? Okay. And if I run this here, 1.345 plus 1.123, let's do that math here and double check. 5 plus 3 is 8, so that 8 is correct. 4 plus 2 is 6. So this addition is correct. Now watch what happens when I change the set precision to 10. I don't get the correct answer. Okay, it's outside the scope of this class. And if you want to, read about it and learn about it, by all means. When I was back in teaching CS 201, we would talk about this. We'd spend a good amount of 1 week talking about this, and we'd show some real examples where production software out there would break because of problems like this. There was an issue, I think, with the Patriot missile system. I think is a recent, not recent, last couple decades example here of this problem here. Computers have a hard time representing real numbers to perfect precision. So this is really important to pay attention to this. I'm doing calculations on numbers that only have, 3 decimal points. So let's change this to 8. Let's see if we can get it to be fixed here. With 8, we might need to go down to 7. Still gotta. Still wrong. There we go. And we get our right answer there. I'll leave that to an exercise to the reader to learn about the IEEE standard and why the numbers are stored that way. I could have picked 2 other numbers here and done this to 20 points of precision, and it would have been, the answer 0, 0, with lots of zeros here. It just kind of depends what the result is. So that's a watch out for you. It's good user experience to print your numbers in the expected numbers of precisions. So if you're calculating, running paces and gas mileage and tax rates and all that kind of stuff, you don't need 5, 10 decimal points of precision, right? If you're calculating, the exact time that you need to be looking at the eclipse with the exact angle, then yes, you need that precision, right? So, okay, so we jump back to the books here. There are some interesting, well, let's talk about double versus float actually next. Okay, so I'm using float here. A double is simply more memory space to hold that number. So this, in your program, it could be an important decision. It's like, do I use floats or do I use doubles? In our class, it totally doesn't matter. Be consistent. You hear this from me all the time. Just be consistent and use double, right? I mean, you might as well just use double. It's going to be more precise. the example that I just gave you, maybe it would work with double versus float. I don't know. I haven't tried that here. But it's just two different types of representing large numbers. Here's another example. I found this in some of my old material from when I last taught CS 161, showing, this is from Visual Studio, showing the value of the variable here as I worked my way through the program here, right? So let's walk through this here. So before I declare my double in line 11, but before I actually give it a value, it's not been initialized yet, and it just has garbage in it, right? Because you power on your computer, and the memory just has random ones and zeros in it, and so you get this, in this case, a ridiculously large negative number, right? Negative 9.25 times 10 to the 61th, right? So negative 925 with another 60 zeros after it, right? It's a massively large number here, right? Okay, but then I work my way down as I run through the whole thing, and you could see, I don't know what's this data. I get a value here of 2.0000, and it's okay here. But if you look here, I actually assigned it to 2.000001, right? Actually, that's not at the bottom. It's line 13. Sorry. So that's correct. Here, I set my value to 2.0001, and you can see this is how it's printed. Not exactly the same. And then here, it's the same thing. Okay, so this is another example showing you those precision challenges when you're using these floating point numbers, which are doubles or floats. All right. What else do I want to do? Excellent. All right. We're going to jump into the discussion project and the assignment here in a moment. Some recap items that we talked about initialization, right? We've talked about assignments never actually move the data. Okay. One thing I skipped over here, this is in section 2.6 of the chapter. It talks about this thing called incremental development. Okay. This is a fancy way of saying test as you go. If I asked all of you to, sit down midterm exam, okay, here's a program, write this thing now. Some of you will code it all out, and then you'll hit run and it won't work. And then you're going to have to figure out where your errors are. You're going to comment out lines, you're going to change things, and you're going to spend a lot of time, and hopefully you'll find your error, but it will take you a lot longer. You're better off building your program in steps. Okay, step 1, get the input data, print it out, make sure it's correct. Step 2, make sure the first calculation, then the second calculation, and so on. Build and test your program. Our environments are so fast, and especially if you're using, like you saw, Replit was like it took 3 to 4 seconds at some point between my runs. But if you're using some of the other tools, it'll be more immediate. You can iterate over and over and build as you go. This is not like ancient times, which is before me even, where you had to write the program and you had to take the program on a stack of punch cards to the computing center and hope that you got your data back in 24 hours. We don't have an environment like that anymore. So you can build as you go. So I recommend strongly that you build as you go. I always keep track of the number of bugs that I see, and students come back and, oh, I wish I had done that earlier, right? Okay, let's jump back. Okay, there's some more floating point stuff that I'm not going to talk about here. Scientific notation and not in numbers and divide by 0 and things like that. As we get later into the chapter here, we get some good examples here, some good meaty examples for you to go through. Okay. And so let's go and look at discussion 2, which I don't have open. Sorry. Let's go there. Okay, so you can use your, it says programming partner. You can do it in your group if you want. You can do it with a different partner. Of course, you can do it by yourself. Okay, but what you want to do here is you're going to write a program to get two numbers, which we're calling doubles in this case. You know what the car's miles per gallon is? It's mileage, right? You know, an example mileage might be 20 or 30 or 35. The gas price per gallon as an input, okay? And where we live, where many of you live in the Portland area and where I live in Seattle, heavy, expensive gas, right? And then output what the gas is going to cost if I want to drive 3 different distances, 20 miles, 75 miles, and 500 miles. Okay, suggesting that you use set precision 2 here so that you only print things out and with 2 decimal points. Okay, let's see what we got here. Let's go ahead and open that. This is the template. Okay, so you can kind of follow through this template. You can use this if you want. And I think that's all we really need to say about this one. So go through the material in the books first. You know, you think about the timing, right? By the middle of the week, you should work on the discussion, and then you'll go on to the programming assignment. Okay, here's assignment 2. Suggestion here is you get a draft of your plan by Wednesday, right? You know, you can, one of the things you'll notice is that these assignments have spots for you to put your book stuff in there. You don't have to do that, of course, either. I'd love to see these drafts by that date. If I don't see it, I don't see it. I get it. Okay, you're going to use your algorithmic design document for this. Let's look at the assignment document. I think I have that open right here. Okay, we are going to create a basic payroll program. Okay, so the stuff you'll do in that discussion about the mileage calculations is going to really help you here. Okay, we've talked about what you need to know to do this. Actually, all of this in this material so far. Sample assignment document is here. It's telling you what your inputs and outputs are going to be, so that you should be able to take that and put that in the algorithmic document directly. Okay. The most important thing I want to point out is that your code needs to look like this. Okay. Don't take liberties. No, there's no points for creativity here. Okay, I want your code to look exactly like this. Remember, I'm grading dozens of these, and if somebody reorders these or they add stuff, it's likely I'm going to misgrade it. So it has to work for these numbers, obviously, and there's 2 examples here, but more importantly, it's got to match this exactly. Okay, so you're going to be doing some calculations here. You can use whatever variables you need and follow the rules that we've talked about. There's some requirements that are listed here. And what I want you to upload is a file called a02.cpp. That's the program. The a02.pdf is the algorithmic document. This can be called main.cpp. That's okay. It could be called, you know, yourjohnson.cpp. You know, I don't care what the name of the program is called, but it has to be a CPP file. It can't be a link to Replit. It can't be a zip file. It can't be screenshots. It can't be the code pasted into a text file. It has to be a CPP file. If it's not, it won't get graded. Okay. From Replit, if you haven't figured out how to do this already, if I want to take this main.cpp and make it available, I'm going to click here. I'm going to download it as a zip, and then once I have my zip file, it shows it. Here's my main.cpp. So this is the file that I'm going to pull out. So I have to take this, and I can take this and I can copy it, and I could put it on my desktop, and I can, so here's my desktop, for example, I can copy it and put it, and then put it into D2L. We're going to be, for this assignment, we're going to be operating in US currency here. So you can see that you have the dollar signs here with 2 decimal points. Okay. All right, let me know if you have any questions about this. Use the discussion boards, of course, and we can have a follow-up session as needed, later in the week. And so go for it and let me know how it goes.